All right, guys, today we are going to do trig modeling. I'll tell you, even though I'm being recorded, that these are really pretty slides because one year I was being evaluated during this lesson, so I made them extra pretty. Okay, but what we're going to do is we're going to read a word problem. We're going to try to sketch a graph of the situation. Then we have to come up with an equation for that graph. And then we have to type it in our calculator and use it to predict another value. Okay, this whole process is so that you could make a prediction. I'm trying to show you how people would really use this, okay? So I just put this little, this is a tsunami gauge network, it says, but basically it's showing tidal waves, which clearly are sinusoidal, right? Which just means could be made into a sine or cosine graph. All right. I put some vocab up here. Sinusoidal, remember, means it could be graphed as either sine or cosine. All right. Here, hours of daylight over the course of, 365 days. Their days get longer and then shorter. That is another thing that is sinusoidal. Okay, so here's our question on the top of your worksheet. Before I do that, though, I want to show you real quick. We don't need sound on this even, but everybody knows what a Ferris wheel is and what it looks like and the height of you. Okay, so if I'm sitting on this red little ride right here, it goes lower, 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 raises, 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 okay? So while it's going in a circle, if you are graphing its height, it's going up and down. Does that make sense? It's going higher, lower, higher, lower. Okay. Oh, Angry Birds. Good. No, that's not what I needed. Okay. So it says, as Rashad rides a Ferris wheel, his distance from the ground varies sinusoidally with time. Remember, that doesn't mean we have to graph it as a sine necessarily. It could be a cosine. Most often, all of the functions we graph, we're going to want to write a cosine equation because we want to say, like, we know the highest and the lowest, and we want to start at one of those, which makes it a cosine. Rarely do we want to start at the midline, okay? When the last seat is filled and the ride starts, okay, so they loaded it all up, and now he's starting the ride. It said his position is at some random spot right here, time 0, okay? It says he determines it takes him 3 seconds to reach the top. So at 3 seconds into his ride, time is going to be this direction. He is at the top, which is 43 feet above the ground. So I'm going to put 43 feet. And put a little dot here to show that he was 3 seconds in and 43 feet up in the air. Okay, he also determines he is back at that original position after 8 seconds. Okay, but we don't know where his original position was. Sorry, guys. But what does that mean? If he's back where he started at 8 seconds, it means wherever we start, it takes 8 seconds to get back there, right? So it's 8 seconds around. So let's think about that. So how long until he's back at the top? 8 seconds, which would be what point on his journey? How many seconds from when he started? Would that be at 11? Okay, 8 seconds later, everybody with me? Okay, now this is a weird thing. We have to get used to this idea. The diameter is 40 feet. Okay, so if he was at the top, and that was 43 feet in the air, and all the way across is 40 feet, what is his height at the bottom of the ride? Yeah, he's still 3 feet off the ground. Does everybody get that? So the minimum is going to be at 3 feet. If you think about when you're on the Ferris wheel, your feet don't hit the ground, right, as you go by. So he's still a little bit above the ground. He's still 3 feet at the bottom. Okay, that's all they give us. But we can make a graph because we can say he started up here, he descended, he hit the bottom, and he went back up. And then he kept going. But I don't care about that. I just want to be able to graph one period nicely and come up with an equation. I'm going to try to draw that a little better. And if yours looks like a V, I'm not going to be picky, okay? All right. Yep, mine still doesn't look very good. Sketch a graph. What is the lowest you go as the Ferris wheel turns? Anybody? What was the lowest we decided? 3 feet. Why is it greater than 0? Yeah, you don't want to cut your leg off. So I'm just going to write, don't hit the ground. Okay, write an equation. Okay, so using this chunk right in here, I want to come up with an equation that would make that graph work. I always start with the midline. Can we figure out the midline? What is this total distance? 40 feet, okay? So halfway is the amplitude, okay? Half of the total distance is the amplitude, because it's how far above and above. So we're going, what is the amplitude? Everybody good? 20 is the amplitude. So what would the line be? 20 above here and 20 below here. Everybody good with what I'm talking about? So the midline is 20 units above, and then another 20 up to the top puts the midline at 23. Now there's another way you can do that. You can actually average those, because mid means middle, right? So 43 plus 3 is 46, divided by 2 is 23. Yes, literally just average them, okay? And that would find you the midline. And then you could just say, well, how far above and how far below, that would be the amplitude. So whichever direction you want to go first. So can anybody put either one of those in our equation? Oh, what are we going to call this? Sine or cosine? What did I do, that red piece there? That's a cosine, okay. Any numbers we know so far? The amplitude is 20, and that goes multiplied in front, right? And the midline tells us what? The vertical shift is up 23. Pretend that says 23, sorry. Okay. We could have put it 23 plus out in the very front, but I don't usually do them that way. Then we got to figure out this period business. What is the length of a period? How long did it take to go all the way around once? 8 seconds, yes? From 3 to 11 was 8, so the period is 8. But that's not what goes in the equation, remember that? What goes in the equation is the b, or 2 pi divided by the period. So you could literally put 2 pi over 8. I wouldn't count it wrong. Do you want me to reduce it to pi over 4? That's the b value, okay? All right. I think we're still not done, though, because we need a little bit of a phase shift, right? This didn't start at the y-axis. How much into the story did we start? So we have to go -3 because it was right 3. Everybody good? Whew. Okay. No, as long as you can put in your calculator correctly. I'm drawing the extra parentheses because actually you do need the runs around x minus 3. You don't need the green ones. You got to do the phase shift in a parenthesis. But in the calculator, you will need all these, okay? So grab your calculator. And I want you to first go to mode. Any trig graphing, we have to be in radians. Will not work if you're not in radians. So go down to radians here and hit enter. And then if you have one of mine, it'll say radians at the top. I think the ones I have in the back don't show you what it is in, right? But it's mode. Mode is at the top next to second. And you have to make sure you're in radians. Then you're going to go to y equals, and you're going to put in this equation, 20, hit cosine, it'll bring up a parenthesis, then you type pi divided by 4, another parenthesis, x minus 3, close both of those parentheses, and on the back you want your plus 23. Unfortunately, it isn't going to graph until we tell it a window, okay? So what window did we use in our story here, guys? We looked at x values, we can say from 0 out to, we only went to 11, but later in the story, I feel like later they ask us to go out to 6 seconds for, I guess they don't really go that far. So I don't know. How far do you want to go out? 15 is far enough? Okay. So for x, we could do 0 to 15. I think I went out further than that, but it doesn't matter. And for y values, yeah, 0 to 50 would work. Just look at what you wrote on your graph, and that's what you need to set it to. Okay. So you guys are doing 0 to 15. I only went to 20, so I can change it to 15. Then scale doesn't really matter, but then 0 to 50 for the min and max for the y. If you wanted to count, by put a tick mark every 5 seconds, that's the scale, but you don't need to worry about scale, doesn't matter. Then hit graph and see what you get. Is it doing what you want it to do? Before you try to make a prediction, okay, go trace. Tell me one value you know for sure is not supposed to be on here. If I put in a 3, it should be at 43, yes? And then what was the end, 11? 11, is it back at 43? Okay. We could try to find this min. Let's see, what's halfway between 3 and 11? 7? I just wanted to make sure it was at 3, okay? So I'm just checking that our equation is working for the story. Okay, now go ahead and read the rest of the questions and try to answer them while I wander around and see who needs some help. And then I'll check your answers. The rest of the answers should just be typing in trace whatever to see if it's working.
What are we rounding to? Is that what are you supposed to round to?
Tenth of a foot or something is fine.
Yeah.
Oh, you didn't put the extra parentheses.
Oh.
You have to have a parenthesis. Let's see. Oh, that's it. I think you just lost that close one. Yeah, because you have this. Practicing getting them typed in is tricky. Anybody else? Not working? Not looking right? 4 1/3. Any ideas? Yeah, you could do 13/3. That's a good idea. So you could go trace 13 divided by 3. What I was going to say, star, 4.333 would work. Otherwise, what I usually do is I would literally do 4 and 1/3. You do have to put it in parentheses, but does everybody see what I'm saying? I'm not going to ask you on a quiz for fraction 1, but 4 and 1/3 always works as well, okay? Good question. All right, let me go back here and see what you got. Okay. Predict your height at 6. What did you get at 6 seconds, guys? 8.9. 8.86. I think you missed that extra 8 in there. That's easy to do, and I always feel bad when somebody at a quiz just rounds funky. Okay. 4 1/3. What was 33, right? We just did that one. 9 seconds. 9 was 23. And what was the last one? Oh, it was 0. Okay. What was this one? 23? I'm losing my mind here. Okay. So if I go back here, times 0. So he was already 9 feet in there. Just means he didn't, when they finished loading, he wasn't the bottom one anymore. So that's all. It kind of makes sense for our story here. Does this look like it could be he was up already like 9 feet right here and going up? Okay. Yay! How you feeling? Was tricky, but let's try another one. All right, this is a different kind of story. It says a weight is attached to the end of a long spring and it's bouncing up and down, up and down, up and down, up and down, okay? I don't know if you've had physics, but if we ignore friction, it would continue to bounce, right? What's the law of motion? Motion stays in motion. Yeah. So, you start a stopwatch when the watch reads 0.3. That's when it reaches 60 centimeters. It's a high value, high point of 60 centimeters. Okay. So, at 0.3, it is at a maximum of 60. Does this sound a lot like the last story? In terms of, we got a max to start us here. The next low point, which is 40 centimeters above. So the low is 40. So sometime we get down to 40. I know my scale is kind of wonky, but okay. The low occurs at 1.8 seconds. So 1.8, we're at the low of 40. Is that a whole period? Okay, if you went from the max to the min, that's not a whole period, right? You would have to keep going. Okay. What do we know? Tell me anything. How long half a period is, what the amplitude is, what the midline is, anything, what function we should use. Midline is what? 50. That seems a pretty easy one. Yes, everybody agreeing with that one? So we're going to have a plus 50 on the back. Go ahead. Okay, so from the top to the bottom was a total length of 1.5 seconds. Okay, so what does that make the full period then? Everybody okay with that? It's kind of a weird one, but from 0.3 to 1.8 was a distance of 1.5. So to get back to the top, it would take another 1.5. Okay. So the period would be 3 seconds. Should I use sine or cosine? Cosine, because we know max to max, or we could have figured out where the next max is. Amplitude? How far above and below we're going? 10. Now, I got to tell you, people mix up the amplitude and the midline when they start writing these equations, and that's a big problem, okay? The midline is at the back, the amplitude is out front. Okay. Now, what is our shift? Let's leave the period alone for a minute. How long did we, into the story, did we hit a max? What am I going to write in here? Yes, minus 0.3 because it went to the right 0.3. Everybody okay with that? All right. And then if the period is 3 seconds, how do we find B? 2 pi divided by 3 will become our B value. So we have to type 2 times pi divided by 3 and then that second parenthesis. Okay, can you try to type that one in? And then maybe try to set the window that you think would work. I'll go ahead and go to this slide so that you can see what I type. By the way, this does say 10. There's a 1 underneath that box. But this is how it should look when you get it typed in right. Okay, I'm going to go back to the story for a second. It wants us to eventually go out to 17.2 seconds. So we really should set our time, all the way out to like 20 seconds, which is going to be really long. It's going to go up, down, up, down, up, down a lot of times, okay? But otherwise, it won't give us 17.2 unless we like go to the table and set it to count by tenths. It's a pain in the neck. It's got to be in the window. What about our Y value? How high should we go? Okay, we could do 0 to 70. That's probably what I would do. That's our Y value, right? You could do just 40 to 60 and just look at that little piece of it. All right. So let's see what I have on mine. I need to turn this one off. Go down and turn this one on. And I need to change my window. What did we do? 0 to how far? 20 seconds? And then 0 to 70. Okay, so I got like 1, 2, 3, 4, 5, 6, 7 maxes in that window. Is that looking about right? Who needs help? Okay, so let's double check. What was it, 0.3? I'm going to go trace 0.3 and make sure I'm at 60. No? Was it not 0.3? Oh, look, my equation is typed in wrong. I have a 0.5 in my equation. Fixing. Because when I typed it in before class, I must have typed it wrong. I had 0.3 written down though, didn't I? Okay, so now when I go to 0.3, it's at 60. Okay, and then was it 1 point? Where was it supposed to be at the low? 1.8? Okay, there we go, 1.8 and 40. So it seems okay. So then what questions are we supposed to ask? Predict its height at 17.2. So if we go out to 17.2, I got 43.3. Anybody else? Yes, thank you, centimeters. Does anybody know how we could have done that without our graphing? If you were super uber confident that your equation was right, you could have on the home screen put a 17.2 in right there. Does that make sense? You wouldn't have had to graph it. You could have just said, I like this equation. I'm going to put the 17.2 in for X. I don't ever do that because I want to know that my equation matches what I think I made it do. All right, what is the distance when you started the stopwatch? So what are we trying to find there? 0, enter, I got 58. Does that sound right? Was it 0.1? Okay, sorry, 0.1. Anybody having trouble? All right, 2 to go. Let's try this third one. A tsunami, commonly called a tidal wave because its effect is like a rapid change in tide, is a fast-moving ocean wave caused by an underwater earthquake. The water first goes down from its normal level, then it rises an equal distance above its normal level, and finally it returns to normal. The period is about 15 minutes. Suppose that a tsunami with an amplitude of 10 meters. Oh, so they're telling us the amplitude. That's interesting. Okay, the amplitude. Oh, I didn't mean to underline that. I meant to underline this. Amplitude of 10 approaches a pier at Honolulu where the normal depth of the water is 9. All right, so normally the depth of the water is sitting here at 9. And our equation is going to have an amplitude of 10. Maybe we do want to do this one as a sine, huh? Because what is the first thing it says it does? It goes down. Now, if it goes down 10, where does it end up? At -1. That's weird. Okay. Now, what would it mean to have a -1 height of water? The beach, like the wave would recede right out, and there would be, you'd be like seeing all the bottom of the ocean right there for a little ways, and then it would come back twice as big. So, goes down, recedes, then the water comes back to its normal height, but it keeps going to twice as, or yeah, to an amplitude of 10. So how high would it get eventually? 19. And then eventually it says it would go back to where it was. And how long would the whole thing take? 15 minutes. So I don't think we want to use a cosine. We could, because we'd have to figure out all these quarter points. But what could we call that? What is that shape? It's a negative sign, right? So negative sign, because it started at the midline, went down like that. Okay. So I'm going to put a negative on the amplitude because it's going to be a reflection, and then write sine. Okay. The next thing we put in our equation is usually the B value. What is our period? Period is 15, so B would be 2 pi over 15. Do we need a phase shift left or right? Not if we're calling it a negative sign, we don't. I think you could get by without those extra parentheses in there, but I'm going to put them in anyway. And midline. +9. So this one wasn't, well, it was weird. It was not. How far do we want our window to go out? It says predict at 2, 4, and 12. So we could do like 0 to 15 for X. And what about the height? We got to have negatives this time, right? So maybe like -5 to 20 or something. Okay. Let's see if Hofbauer has it typed in correctly this time. I have -10 sine 2 pi over 15 x plus 9. Is that what we got, guys? Okay. Go down and turn this one on. And then I'm going to go to my window. What did we decide to do? Was it 15 seconds or 20 seconds? We said 15. And then we needed the min, y min, -5 to 20. Okay. I'll leave my window up there for a minute. How we doing? So my equation says y equals -10 sine, brought up a parenthesis on its own, and then I type 2 pi divided by 15. Then I put parentheses around the x plus 9. I think it would work without those parentheses. Okay, this is what I got. Anybody else? Actually, I'm kind of confused. Isn't the period... Oh, it was 15 minutes? And we only went out to what? Oh, so if I went out... I was like, it looks like exactly one period. Yeah, if I went out a little further to like 20, then I would see it. Okay. I just wanted to make sure that... Okay. 15 is fine. Yep, 15 is fine. Predict the depth of the water at 2. Okay. Anybody tell me? Where were we at 2? 6 meters? 1.6 meters. Okay. 4 minutes. Negative, one more time. Okay. Yeah, I don't care. -1. 12 minutes, I mean. 18.5. Okay. Yeah, trace 4 minutes. Yeah, -0.9 or -1, somewhere in there. Okay. According to your model, what will the minimum depth be? -1. How would you interpret this in terms of real world? I usually just say like the water would recede or go back. Do you know what I'm saying? Like you'd see, I don't know if that's how you spell it. How do you spell recede? E-D-E? Yeah, I was gonna say, I don't think that's right. Anyway, I don't really care if you answered that question. It's your notes, whatever, we're good. Last one. No, doesn't ask you. No, yep, good question. All you have to do on the quiz is it'll ask you like one of these predict questions, not 4 of them, but one, okay? When a satellite or rocket is launched into orbit from a site such as Cape Canaveral in Florida, which is not on the equator, it goes eventually into an orbit where it alternates exactly the same distance north and south of the equator. Its distance from the equator is approximately a sinusoidal function of time. Suppose that a satellite is fired into orbit from Cape Canaveral. 10 minutes after it leaves the Cape, it reaches its furthest distance north of the equator, 4,000 kilometers. Half a cycle later, it reaches its furthest distance south of the equator on the other side of the Earth, 4,000 kilometers south. The satellite completes an orbit every 90 minutes. All right, it says let y equal the number of kilometers the spaceship is north of the equator. So then south of the equator can be negative numbers, okay? Let the number of minutes that have elapsed since liftoff be time. Okay, so at one point in the story, it goes 4,000 north, and then it ends up at some point 4,000 south, which we're going to call -4,000. Okay? But where does it hit 4,000 north? Did it tell that? 10 minutes. Okay. I was missing that little piece there. 10 minutes after it starts is when it hits the north, right? Okay. Now, what is this 90 minutes business? That's the period. So if we were drawing this, it goes down to the equator, down to the bottom, back to the equator, back to the top. Is that last point 90 minutes? It's not. Does anybody tell me no why that's not at 90? Because we started at 10. 90 is this length, but that puts that last point at 100. I really don't need to know that last point. I just need you to understand that the 90 is the period. All right. Write an equation. What do you want to call this one? Cosine, what is its amplitude above and below the midline? 4,000. Do we need a negative 4,000? No, the shape of the cosine, right, goes max to max. We're good. If the period is 90, then what goes into the equation is 2 pi over 90. I think I actually typed 2 pi over 90. You can reduce to pi over 45 if you want. I just left it so that in your notes it would make sense where it came from. Is that all right? Do we need a phase shift? 10 minutes in, so x minus 10. Do we need a vertical shift? The midline's just 0. We don't. Okay, so type that in. And I'm going to call on some people, so you better be typing. Figure out a window that works. How long? Oh, down at the bottom it says goes out to one. We have a question about 163 seconds in, right? So I think I'll just go out 200 seconds or something. And then I need like a negative 4,500 and a positive 4,500 for my max and min. So my x was, I went, I think 200, but you just have to go past 163. And then my y was, I did negative 4,500. You could have done 5,000 to positive. Okay, so we got to remember, are we north or south of the equator? At 25 seconds. Ben, did you do 25 seconds? Little louder. 2004? North, 2000. Oh, sorry. Yeah, it's my earbuds. My ear. Yeah, I can't hear whatever I'm trying to say. Did someone else get that answer? Okay. Natalie, did you try 41? 2236? South, so it must have come up as negative. Everybody agreeing? 163. Emma, did you get to 163? Can you say it one more time? I can't.
Negative 1,236. 1,236.
And that was south, so it's negative. Okay. So it had a negative out here on both of these. All right, what is the actual, when it took off, how far was it north of the equator? So at time 0. What do you have that one? 3064. Okay, and that was north of the equator. Okay, look, I looked it up online, and it says Cape Canaveral is really 3154 kilometers north of the equator. So we're off by what, 90? That's not bad, right? It's a pretty good predictor. And when it gives you Cape Canaveral on the Google, it's not necessarily exactly where you were there. It's like the middle of the town is at that. Anyway, I was just trying to show you it is actually a reasonable example. Okay. So you have to go to worksheet 22 and do these 4. Now, I don't know that they're all as complicated as the ones we just did, but 1, 3, 5, and 6, okay? I don't think I ask you as many random questions on those. 1, 3, 5, and 6, okay? Please practice this. I can't stress enough. This is not something you can just watch Hofbauer do and go, oh yeah, I got it.